Hey y'all, I really need your help today. Yesterday, I had put up a milkshake counter in my neighborhood carnival. I've tabulated the data of the number of milkshake glasses sold every hour, but I can't draw any conclusions from this table at a glance. What if I use pictures to represent the data? Let's use a milkshake sticker to represent each glass of milkshake. In the slot from 1 to 3 p.m., we sold 20 glasses. So let us replace this with 20 stickers. Next, in the 3 p.m. to 5 p.m. slot, we put 10 stickers. And for the 5 to 7 p.m. slot, we will have to put 35 stickers. Oh no, I don't think I have so many stickers with me. I have an idea. Let's say that one sticker represents 5 glasses. Now, how many stickers would I need to represent 20 glasses? We can find the number of stickers by dividing the number of glasses of milkshake by 5. So, 20 divided by 5 equals 4. Therefore, 20 glasses can be represented by 4 stickers. Similarly, to represent 10 glasses, we'll put 2 stickers. To represent 35 glasses in the slot, we'll put 7 stickers because 35 divided by 5 equals 7. And for the next 2 slots, we will put 6 and 10 stickers respectively. Doesn't this look cool? I can so easily relate the data through this representation. When we represent data using pictures or symbols, it is called a pictograph, and this is called the scale. The scale tells us the number of observations each symbol represents. Now, let's see if we can answer questions using this pictograph. In which slot was the least number of milkshakes sold? It's 3 p.m. to 5 p.m. slot, since it has only 2 stickers. How many glasses were sold in the 7 p.m. to 10 p.m.? How many glasses were sold in the 7 p.m. to 9 p.m. slot? Count the number of stickers in that slot and multiply it with the scale. 6 stickers multiplied with 5 is equal to 30 glasses. Good job, guys! You really helped me make sense of all the data I collected.